Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the number theory and abstract algebra chapter. This is our second question. This question asks us to find the least common multiple of 1001 and 10,101, and then what's the sum of the digits of that least common multiple. Well, what you have to remember here is a couple things. First of all, there's an important theorem that says that the least common multiple of two numbers times the greatest common divisor of those same two numbers is equal to the product of the two numbers. Okay, so this is an important theorem that you have to remember. And this is really helpful because if we know how to find the greatest common divisor, we can use the Euclidean algorithm, which I'll show you in a sec. So once we find the greatest common divisor, we can just take the product of these two numbers, divide it by the greatest common divisor, and that'll give us the least common multiple. Okay, so this is important right here. And now we're going to use the Euclidean algorithm. And if you remember from the last problem, the way to do this is to write 10101 is equal to some number times 1001 plus some remainder. Well, how many times does 1001 go into 10,101? Well, 1,000 goes into 10,000 about 10 times. So I'm going to write times 10. And how much will that'll give us 10,010. So how much do you need to add to that to get to 10,101? 91. So 91 is our remainder. And now we have to take 1001 and divide it by 91. Well, how many times does 91 go into 1001? Well, 90 goes into 1000. Let's see, 10 times maybe, that'll give us 900. Maybe 91, and it'll give us 910. And then I think we can squeeze in another 91 in there. Yeah, so this 91 times 11 is going to give us 1001, and we don't have a remainder, so there's no remainder. This tells us that 91, this is our greatest common divisor. Okay, and actually we also know that 1001 is equal to 91 times 11, and 10,101 is going to equal, well, let's see. If we can just take the product of 10,101 and 1,001 and divide that by 91. Another way to do this is to notice that 10,101 is going to equal, let's see, 1,001. That's 91 times 11 plus 91. So this is actually equal to, I'll write this out, 91 times 11 plus 91. That's going to equal 91 times 12. Oh, sorry, I forgot, there's a 10 here also. So 91 times 11 times 10. So how many 91s do we have in here altogether? We have 10 times 11, that's 110, plus some 91, plus 1, that's going to give us 111. Okay, so if we write out the factorizations, we can see that this 10,101 is 91 times 11. 10,101 is 91 times 111. That means that the least common multiple is going to equal, I'll write this out, 91 times 111 times 91 times 11 all over the greatest common divisor, which is 91. So one of the 91s gets canceled out, and then we end up with 111 times 91 times 11. Well, we know that 111 times 91 is 10,101. So we just have to multiply that by 11. And what do we get? 1 times 1 is 1. 0, 1, 0, 1, 1, 0, 1, 0, 1. Our answer is 1, 1, 1, 1, 1, 1. And then the question is, what's the sum of the digits? So we get 1, 2, 3, 4, 5, 6. So our answer is A, 6.